Hi IB. We're looking at 20E, which is cumulative frequency graphs, and we're just taking what we know about histograms, and we are now going to apply it to a cumulative frequency histogram and turn it into a cumulative frequency polygon or ogive. So the last few days we've been looking at histograms, which is the graph of basically cumulative frequency of columns. But now what we're looking at is once we make the cumulative frequency columns as our histogram, we're going to connect the bottom, well, starting at the bottom right corner, we're saying this is basically 0 here. So starting at this corner, we're going to connect all the top right corners because what we're looking at here is basically percentiles. So the reason that we actually connect the right corner is because we're saying that, all right, at this point here, 0%, because here's 0% along the y-axis, 0% of our scores are below whatever this x value is. Then we have a certain amount of percentage of scores that is below or equal to, I guess, this x value. Then we have a certain percentage that's below or equal to this x value, and this pattern continues and continues. So we use the top right corner of the column just to say that all the scores are below or equal to this top right corner. Whereas when you're just looking at frequency instead of cumulative frequency, each one is individual and we're not comparing it to the whole. Whereas here with cumulative frequency, we stack up, and then at the end, whatever this highest frequency is really our total number of data values as well. So a few ways that we can look at this. Now this one's a little bit different, not quite as even. So notice that this one, the frequency would have been very even across all of our categories. And so the difference between each of our columns as we add on is also very even. So these are also very, very similar differences every time that we add on a new interval. For this one though, we've got a little different frequency going on. So it shows a little bit more of a curve. And then you'll notice that the difference between each of these columns, the height of each column is also very different because we have a lot being added here, as you notice, and maybe a little bit here, as we notice, and so on and so forth, okay? But for this one, just be thinking about how we actually would interpret this. We really want to talk about the x values, and our frequency is still along the y-axis. So if we were looking at our median, if we lined up all of our x values, we wanted the middle value, we would still be finding the middle based off of our y-axis, and then we can track it back to the x-axis to say, well, what value is actually in the middle of our data? And that would be lining up from least to greatest, just as you would do it by hand. So we call the shape that we make a polygon because it really is a closed shape. We're starting along the x-axis, we're connecting the top right corners of each bar, and then we end in the top right corner right at the max of how many total values we actually have if you added them all together. So we call this a polygon or an ogive. We've discussed a little bit about why we connect the right corners because we're talking about percentiles. And with a percentile, the definition of a percentile is that every value at or below this point is going to be, you're going to be looking at whatever this corresponding x value is. So the whole idea of being in the top right corner is you're saying that a percentage is at or below a certain x value. And we do connect with lines, even though if you had several columns, it would start to look like a curve. But we do connect with straight lines because definition of polygon as well is straight lines that make a shape, a closed shape. So in order for us to actually interpret our cumulative frequency graphs or polygons, we do need to understand this idea of a percentile. So a percentile is when you have a score below which a certain percentage of the data lies. So for example, your Q1 is the 25th percentile, which means 25% of your data is at or below whatever that corresponding x value is. So looking at an example, if the 15th percentile is at 46, then what we would say is that 15% of the data lies below or equal to 46, which consequently means that 85% of the data would then be above 46, okay? So you do have to read the questions very carefully, deciding, does the question want you to find a percentage below? So do they want you to find a percentile, or do they want you to find the top 2%? So just another example, I'll put up on the slide here. If I wanted to find the top 2% of a class, let's say, that means I actually want to find that corresponds to the 98th percentile, because that would mean that 98% would be below whatever X value we find. So 2% would be above. Well, that means we want 98% to be below. So this would be the percentile we would actually be looking for. So taking a look at an example here, we don't know what we're measuring here. We know that we have scores, but we're not given any scores along the x-axis. So these are just general x scores, whatever they happen to represent. But we have 240 total scores that we've collected, which would mean 120. The 120th score would be our median. However, we wouldn't write down 120. We would want to write down whatever the score is that corresponds to 120th position. Because again, if you lined up all 240 scores, you would want the 120th score, right? So we're looking down on the x-axis when we write down our answers. Same thing with the lower quartile and the upper quartile. There's our 25th percentile and our 75th percentile. So for example, if you were asked to find the 60th percentile, I would take 60% of 240. That's my total, and that gives me 144. So I would want to trace back at about 144, which should correspond to 60%, would be about here. And I would want to track that back down to the x-axis to figure out what score is actually going to correspond to the 60th percentile. If I wanted to find the interquartile range, I would need to find what the x value is for Q3, what the x value is for Q1, and then I would need to subtract the two. And that would give me what my actual IQR is. All right, but remember we are subtracting the x values because that's actually what we're measuring, not the position on the y-axis that they're lined up as. So to prepare for next class, I'm going to get you guys started on example 10 from your textbook, and then I'll let you guys try to finish it off. So you guys are given the finishing times for the 2008 Olympics, the women's marathon, and you notice the way that the intervals are set out, that you have times between 2 hours and 26, 2 hours and 26 minutes and 2 hours and 28 minutes. But this is a strictly below 2 hours and 28 minutes. So we're including anybody who did hit 2 hours and 28 minutes in the next interval. So we include the lower end, but we do not include the upper end. And then this is our frequency for each of the intervals. So our first job is to construct a cumulative frequency distribution table. So anytime that we are constructing a table and we have intervals given to us, we want to find the class center, correspond that with the frequency, and then now we also want to find the cumulative frequency. So again, we've been doing this with a couple of the examples, but anytime that we have a cumulative frequency table, we need to have a cumulative frequency column, and that last number should tell us exactly how many total data values we have. So here we have 69 runners that we're looking at for the Olympics, which would mean n plus 1 would be 70, so the 35th score would be the median. So if I take a look at this chart, my 35th score will fall in this category. So I'd be looking at a median score of 155. I can similarly find my first quartile two ways. One, I could either just, again, break down my 69 values, I guess. So between the 17th and the 18th value is where my Q1 would be. So that was at 151. And I think we changed all of these to, yeah, the class center would be the total minutes. And I could do the same for Q3, and I can find my between the 51st and 52nd. Now, another way is to find Q1. I could also just take the 25th percentile, so I could take 25% of 69 and find out what that corresponds to. And Q3, I could take the 75th percent of 69 and find out where that corresponds to. So you guys have a couple options for how you find your Q1 and Q3. Subtract, find your IQR. So you can do a lot of analysis with the data that you have as well. So now the new part in this section is actually creating a cumulative frequency graph. Okay, so we'll set this up together and then I'll let you guys try to work through section C to answer the questions using the graph. So if I want to create a cumulative frequency graph, notice we have 8 runners who are at or below 147. So on this graph, this first point here corresponds to 8 runners that are at or below 147 minutes. So this is our minutes, here are 8 runners. Our second value is we now have 11 total that are at or below, not 147, we want to use this, the top, 2 hours and 28 minutes. So now we're using 2 hours and 30 minutes for 11 runners total. So here's our 2 hours and 30 minutes, and we have 11 runners total. So every time that we add another interval, we're saying this next total is at or below this next max. So our next point would be, we have a total of 20 runners that are at or below 2 hours and 32 minutes. So on our graph, we have 2 hours and 32 minutes here, and we have 20 runners that corresponds with. So we're going to continue to plot our points until we get to our max, where we have 69 runners that are at or below, strictly below on this one, 2 hours and 56 minutes. So again, just look at how the intervals are set up. This one says that the max end is strictly below, so that my total runners is actually below the top end. All right, and that's how that would wind up. So now using this graph, see if you guys can answer these questions for part C. And we'll wind up going through these on next class.